Welcome, Matriculants. This is your favorite show ever, the Learning Show on Learn Extra Live 319. I hope you are up and ready to learn more with us. Otherwise, I'm joined now by one of my favorite teachers. I've seen her and I was like, yeah, this teacher, I wish I got her during my times. But otherwise, here's Lee. How are you, Lee?
I'm good, thank you.
I'm also good. We're going to be joined by Lee taking us through to some mathematics. I hope you're up and ready, mindsetters. Otherwise, let me tell you what you need to know. One, you can chat with us on Facebook, like our page, and the 51,520 mindsetters that are talking on our page. That's where we can interact with you. You can ask us some questions. You can also help other mindsetters. The Facebook link is facebook.com/learnextra. The second thing that you need to know is that you can follow us on Twitter. Yes, we are just everywhere. Team, follow us and we'll follow you back at LearnExtra. Lastly, you can download your notes all for free on learnextra.co.za/live. They are also for free. And what we try to do at all times, it is to post the links on our Facebook page and make sure that you enjoy them. Lee, are you up and ready?
I hope I am. Hopefully radioed for sound.
What are we going through? What are we going through today?
We work with Euclidean geometry today, and it's one of my favorite sessions. I really
All right. All right. We're going over geometry. Mindsetters, as we're going over geometry, I just want you to get ready. Get your pens ready, your calculators ready next to you, because after this, we'll get straight to learning. See you after this break. Welcome back, Matrix. Now, we don't have any more time to waste. We're going to get straight into learning. If you're joining us right now, you're a bit late, but nevertheless, you can still catch up. I am with Lee. How are you, Lynn?
I'm really good, thank you.
I'm also good. You just reminded me of Jackie Chan. So your name is
That's
Lee.
right, Lee.
So I was like, are we having a Chinese in the
I'll
building?
have to try some kung fu.
Kung fu in mathematics, right?
That's right.
Right.
Yes, sorting that
Are you
out.
up and ready now?
Yes, I'm up and ready, and I've got the sound blaring, hopefully, and you all can hear me. I must just tell you, I'm really passionate about geometry, so I'm very glad we're going to be doing the topic today.
Let's get into it.
Let's get into it.
Right.
Let's go to the first question. Okay, this question says, we're looking at a typical exam questions relating to Euclidean geometry. And so we're going to go and look at the first one here. These have been taken from exam papers and in particular chosen for the variety of types of learning you have to do. So let's have a look at it. It says CD, let me not take it too high, is a tangent to the circle ABDEF. Now what I do whenever I get a geometry question, the first thing I do is if it's a tangent, I make sure I highlighted a particular color. So they've told me this is a tangent. Now why I'm doing that is if I don't do that, I may forget that fact later on, and it might mean I don't get the question out, which would be rather tragic. So now what else do they tell me? They tell me that the chord AB is produced to C. Well, that's just easy stuff. Chord BE cuts chord AD at H and chord FD at G. AC is parallel to FD, an important fact as well. It says check, yes, they have marked that in for me. That is parallel to that. Again, highlighted in some way so that it's clear and easy for you to remember. And then they tell you that D4, I think it was, is equal to X, and D1 is equal to Y. Right, now we're ready to look at the question. Now, another thing I find is quite important when you're doing geometry is to make sure that you keep your theorems in your mind as pictures. So when I look and I see a tangent, I immediately think about the theorems in picture form of this particular fact. So I know that the one theorem says if I have a tangent and a diameter, that's a right angle. However, there's no diameter here, so they're unlikely I'm going to use that one. And the other one says if I have a tangent and a chord, then the angle between the tangent and the chord is equal to the angle in the alternate segment. And well, there's a very good chance I'm going to use that one. Now, the first question says to me, find 3 other angles equal to x. So what I call is chasing the x. So here I have it, and I can see, look, there's a picture exactly right. There's my tangent. There's my chord. Let's highlight it in green. So the angle between the tangent and the chord is equal to the angle subtended by that chord. So it's going to be up here. I think I was pink. So that's going to be x. So there's the first one. Now, once I've got that one, a good idea is to say, okay, what other theorem can I use with this new x I've got to chase it? And I can see there that we can use this theorem that says angles in the same segment. I know that some teachers call it a bow tie or whatever, but that's what you could look at, and you can see clearly that if we're looking at BD, it traces to A and back to BD, which has just happily moved from where it was. Let me just get the pointer and move it back where it should be. Now the x is moving too. Okay, sorry, my just made that really awkward. Anyhow, it's good enough for now. It's not going to be any harm. You just cut it, maybe. Cut, yeah. Okay, so back to the pens. So if I look at that, I can see that this E2 is also an x, because there's that like bow tie or bunny ear shape to the angles. So I've got two angles equal to x. Notice I haven't written down a thing yet. All I've done is chase the x through the drawing. So once I'm here, now I need to find one more x. And now there's a useful little theorem that we have, and it says, if I have a circle and I've got chords of equal length, then the angle subtended by the chords of equal length is also equal. So that one equals that one. So looking at that, the chord AB is the same length as the chord FE, and therefore I can take that and also give that x. So if I look at it, using that there, hang on, no, that's not going to help me. Sorry, I'm being silly. I've just realized, excuse me, that if this is the chord and that's the chord, it's actually the y I'm going to get. So since we mentioned it, I'm going to put it in. But we still have to chase the x, and I see the x is in the wrong spot, so let me just drag it back. Right, so we need one more x. We've got the one x there and the one x there. We need two there, so we need one more. So I need to look for one more fact. So if I look at it, what else can I see that could possibly be x? I've used those theorems, and I've used the one I showed you earlier on. So let's think about it. I'm now just looking at it. That's x and that's x. Oh, the parallel lines. How can I forget the parallel lines? That's why I say it's a very good thing to highlight them. That way it keeps you focused, remembering about the parallel lines. So if those are parallel lines, and that's x, I know that this whole angle here, oops, I went too far. Oh, sorry guys, I'm having some fun with the eraser. Back to the pens again. This angle over here is also x. What am I using? I'm using the fact that if it's like a Z shape, those parallel, then this angle equals this angle, and those are called alternate angles. Right, so now I've chased my x. I've got three angles equal to x. I now write it up. Remember, when you write up geometry, you make your statement and you immediately give your reason. Without that, they don't, they're not going to look at your drawing. Let's put it that way. They want to see the actual writing. So let's have a write up now. So I'm going to do it down here. So the first thing I did is I said that D4 is equal to A. So I'd write it down, D4 equals A, and the reason is tan chord theorem. Very important you give a reason. If you can't remember the abbreviation, write it out almost fully if you like. That way you can be sure that it'll be accepted. But usually you guys by matric level know your reasons, so I don't think there's a problem with that. Right, what is the next one we said? The next one we said is that this x is equal to this x, so E2 equals A. So back we go here. A is equal to E2. And by the way, they're equal to x. I can also add in the x there. And the reason this time is angles in the same segment. And then the last one we did is the parallel line one. Of course, any order is fine, where we said A is equal to D2. So we say A is equal to D2. And the reason for that is alternate angles. But remember, we can't just say alternate angles because that doesn't make them equal. What makes them equal is the fact that the lines are parallel. So we were told that AC is parallel to FD. So we write here AC parallel to FD. Okay, now that's a nice setting out. They can see clearly how you were thinking. They can see clearly the reasons you're giving. Now, obviously, that was your grade, your circle theorems as such. Now we're going to move out of the circle theorems a little bit, I think, if I remember rightly. And you can see what they're asking for now is to prove that these two triangles are similar. Now, remember that whenever you see similar, and this is very important, if they've used that sign, they are actually telling you that B equals F, H equals E, and D equals D on those two triangles. Now that's very useful because if you're stuck, you can use that and then look for the reason for why they're equal. Hopefully you've already got that point already. So let's have a look at it. So we want triangle BHD. Sorry, let me just go back here. BHD. BHD, this yellow one here. And let's make a blue one of the other one. FED. Notice that I love color and I go out of my way to make sure that I use it fully because in actual fact it makes a huge difference. It makes you focus on the part of the drawing you need to focus on. So that's why it's quite important that. So once we're here now, we're looking at this picture and we're saying to ourselves we've got to try and find at least two angles equal. Once we have two angles equal in a triangle, automatically the third is equal because we know all angles in a triangle add up to 180. So that's our intention. So let's have a look at it. Well, I can see that we've been chasing x's and y's, so let's have a look at what we have here already. So they told me that B equals F, effectively. So let's go back there. B equals F. Can we see why that would be the case? And I'm sure you can. Can you see the angles in the same segment again? Okay, it's a different version of what we had just now, but it's the same theorem. So we can safely say that, so we can write that down. Remember, when we set this out, we would say, first of all, in triangle and triangle. So you name the two triangles that you're going to work in. This helps your marker to understand what you're doing, so it's BHD. And the other one was FED. And we know that angle B equals angle F. Now, of course, we must just be careful. We are naming an angle in a triangle, but if we have a look there, the B they're referring to is B2. And B2 is equal to F. There's no other angle at F, so it's fine. So here we must go B2, and the reason is angles in the same segment. Some important facts is to make sure that these facts, these angles are underneath that triangle, and these angles are under this triangle in the second thing. That way you don't get confused later on when you get your ratios. Right, now obviously then H is equal to E, so let's see if we know that already. Is H equal to E? Definitely not obviously at the moment. But then the third angle is D equal to D, so D is this guy here. And D is there. And of course, what do we know? That we know those are both Y. Remember, we established that earlier on when we were playing with the X. So we can go to that. And remember, it was actually D1 and D3. D3 belonging to the first triangle, and D1 to the thing. And the reason for this is they are angles subtended by equal chords. Okay, now we automatically have the third angle. So we can say, therefore, the third angle, which is H2, must equal the third angle in this drawing, which is E1 and 2, I think. Yeah, it is. So we can safely say now H is equal to E1 plus E2. And again, we would give a reason, third angle of a triangle. And as I've explained to you, we've already discussed that that's the case. So now once we're here, we would say triangle. Now you can use the order they've given you, but I like to use the order I've proved. So it would be BDH is similar to triangle FDE. And the reason this happens is because I've proved 3 angles equal. You can also write equiangular triangles. Right, so the last part of the question says, hence or otherwise, prove that AB times BD equals FD times BH. Now the good news is we can basically use exactly what we've done already. I just want to write that down so I can see it. AB times BD equals FD times BH. Right, so let's go down there. So C, we're required to prove that AB times BD equals FD times BH. Right, so now we look at this. And remember how it works is once we've got the similarity, we literally take the first 2 over the first 2. So BD over FD equals the last 2 over the last 2, DH over DE. And the first and last over the first and last. Of course, don't show them those lines because that's a kind of cheat, over FE. And what do we want? We want AB, which isn't here. We want BD, which is here. We want FD, which is here. And we want BH, which is here. So this fraction is of no use to me. So this would be from similarity. Right, so now we go over here and we cross multiply it. So it's BD times FE equals BH times FD. But we can see it's not quite what we want because they wanted AB. But earlier on, what did we were told? In our drawing and in our given, we were told that AB equals FE. So if that's the case, we've got no problem. So we go back here and we can say, but AB equals FE, reason given, and therefore AB times BD equals BH times FD. And that brings us to the end of this question. It was perfectly timed because I think we're about due for a break, aren't we?
Yes,
Good.
right on time.
There you go.
Talking about being on time, mindset is be on time now by applying or nominating your teacher for the amazing Stars in Education Awards. The closing date is the 7th of September. So if you know that amazing teacher whom you think they deserve a chance to be awarded, so go to www.ed.org.za and nominate your teacher. See you after the break. Welcome back, Matrix. Now, if you're still clueless on what is happening, this is Learn Extra Live, and we're doing mathematics for grade 12s. It is geometry. I've asked a question over our Facebook page. For question 1, I posted the question, Lee, and I asked the mindsetters, can you try this question out? And a very positive and not so positive response that I got. Most of the mindsetters, such as Zasembo Mkiza, say, why is math so difficult? And Wuteko saying, clueless, this is too complicated. But here's a nice one. Nongaba actually says, I'll try it. I'll give it a try.
Now that's the attitude we want to see. Because if you try it, you actually can get some marks. And even if you can't prove the whole thing, you can get part marks. And I'll show you what I mean by that as we do the other examples.
I like that actually, because there's a quote that says trying is just a means, making a mistake is just a means of saying you are trying something.
Correct.
So give it a try and make a mistake. Don't leave any question blank, and don't just say, this is just not for me.
You see, I think that's a mistake that most teachers make, is that when we go and teach, we've prepared the lesson. So yeah, it looks all nice and slick and it all comes out right. But in actual fact, sometimes teachers also get stuck and have to grapple. So don't be scared of getting stuck. It's a good thing to experience and to not panic and to try a little further. So let's try and help you with a few ideas. Yeah.
All right, I like that. Let's continue. Hope that will give you some oomph and motivation.
Let's look at the second one, yeah? By the way, you might notice these are all DBE papers, so they are, sadly, what you are expected to do. Obviously, I've chosen very nice questions that are demanding, so it's not a straightforward question. So just know that not every question looks like the ones I'm doing with you. There are some easier ones. Okay, now here it says to me, ABCD is a palm. Now, straight away, I want you to think back to grade 10 and think about what is important about a palm. Well, first of all, we know that if we have a palm, the opposite sides are parallel. The opposite sides are equal in length. But a very important fact which we often forget is that the diagonals bisect each other. So this diagonal equals this one, and this one equals this one. Also, we've got the angles that are equal and all sorts of things as well. Right, so let's go to the actual question, and let's see what we have to do. So now it goes on and it says, the diagonals intersect at F, so the diagonals that I've mentioned to you are going to be useful. FE is drawn parallel to CD, so that's good news. They've actually marked that in for you, but remember what I said to you about highlighting so you don't forget. AC is produced to P, and now this is quite important. They tell me that PC is equal to twice AC. Now my advice to you is to go PC over AC equals 2 over 1, because it's a fraction. And then to say to yourself, I can't just say that PC is 2 units and that's 1 unit, because we don't know what the unit is. So what we do is we bring a variable in as a kind of holder. So what I would do is I'd say, right, that means that PC is 2A and AC is 1A. Now that's quite useful to know, so let's change to yellow so we don't confuse the issue. So what am I saying to you? I'm saying to you that this is 1A and this is 2A. Okay, so whatever the A might be, it might be 10 units, it might be 50 units, it might be 3 centimeters, it doesn't matter. Proportionally, that's correct. So we just placehold with a variable. Right, now it also tells me that DQ is equal to twice AD. So we do a similar kind of thing. We say DQ over AD equals 2 over 1, but we can't use A again, so let's use B. It doesn't really matter what you use as your symbol. So what do we know? We know that DQ is 2B, and this here is 1B. Now these are your similarity theorems, and obviously they are different in the sense that you use a lot of your, let me just get this to extend, it's not been so nice to me. Okay, right, there we are. Now it says show that E is the midpoint of AD. So what did they do? They told me that ABCD is a palm. So let's go there and let's just highlight this palm. And if it is a palm, we've got all the qualities of a palm. They want me to prove E is the midpoint of AD. So ultimately, they want me to show that AE is equal to ED. Now remember what I said to you. Don't forget that your diagonals bisect each other. So if I look at this drawing, because it's a palm, I can say that FCF, or FC, is equal to AF. And the reason for that is a diag of a palm. That's a property of a parallelogram. If you remember back to grade 10, you would remember that fact. Right, then it says, prove that. So let's think about how that would be possible. Well, going back to our theorem, we learned that if we have a triangle and there is a line parallel somewhere in that situation, then this over this equals that over that. Now, it so happens that we've proved this equal to this. So by conclusion, that must equal that. But we can also use our grade 10 theorems. We can say in grade 10 we learned the midpoint theorem. And the midpoint theorem said if we've got a parallel line in a triangle and it bisects the one side, it bisects the other side as well. So we can use that, and that's perhaps an easier way of doing it. So let's do that just to get it. I'm not having much luck with my pen dragging it down, so we're just going to use good old finger style. AE is equal to ED, and this would be a corollary. And you say, why are you using such an awful word? But just a corollary just means a result of midpoint theorem. So you may agree with me that midpoint theorem actually said that if we draw, take the midpoint of one side and the midpoint of the other side, we join the line, then that line's parallel to that line, and this length is half of that length. So that's what the theorem says. This is the result of that theorem. So that's why I say corollary. You could say resulting from midpoint theorem, same thing. All right, so we've managed to prove that ED, back to our drawing, is the midpoint. So we know that this equals this. So if I were thinking of what I called it B, that would be a half B and that would be a half B if we wanted that. Right, so what's the next question? They ask me, prove PQ parallel to FE. PQ parallel to FE. Let's get another color. I love colors, as you can see, as much as possible on the drawing. Sometimes I get a little bit carried away and the drawing starts to look a little bit messy. But the good news is that in an exam, oh, this has just been so stubborn with me. In an exam, they would give you two drawings. There'd be the one on the question and the one on the diagrams sheet, so it would be fine. Sorry, they were asking for PQ parallel to this one over here. So let's just take that off because we don't need it anymore. And that's the nice thing about me. I can do that. You're not so lucky, I'm afraid. So you know what you can get, and it's quite useful if you look around in the stationery shops. You get pencils, they're pentel, and they actually erase. So you can get different colors and you can erase them. So if your drawing starts to look like mine does, you can do something about it. Okay, so we're trying to prove that parallel to that. So let's talk about how we're going to do that. Well, earlier on I mentioned this theorem that talked about if we have parallel lines, then the sides are proportional. So if we can show that the proportion is the same on the yellow and on the blue, well, we've got it. And can we do that? Yes, we can. We've just done that when we were writing up our A's and B's. So going back here, we can say, and I think I need to have this drawing miniature size for me, that PC over AC, so PC over AC is equal to 2 over 1, and that was given. That was part of our given. And then they also told me that dq over AD is also that. So dq over AD, I think it was, is equal to 2 over 1, also given. So therefore, we can conclude, I'm going to carry it on underneath here. Therefore, I'm having fun with these. Sorry, guys. Sometimes I touch the screen and I really should not. I think I need to ban my fingers from the screen. So if we're looking over here, we can say that PC over AC equals DQ over AD from what we've just been given. And therefore, we can say that PQ is parallel to FE. And the reason for that is the sides are proportional. It's actually the converse of the first theorem that says if we have a parallel line, then the sides are divided proportionally. I'm now saying because the sides are divided proportionally, the lines are parallel. Same thing. All right, now the last question says, if PQ is 60 centimeters, calculate the length of FE. So let's go and have a look at that one. So they're telling me this is 60, and they're asking me to come and find this one here. Well, we've just proved proportion, but we could have just as well proved similarity. So let's go to similarity because that's quite interesting. So if I can prove triangle ACD, so in triangle ACD and triangle, remember I said you always write the things out, APQ, we need to find 3 angles equal, or 2, and the third's automatic. So if I go back there, obviously A is a shared angle. So if A is shared, I know A is equal to A. And because these are now parallel, we've just proved it, this angle here equals this one, corresponding angles, and likewise this one equals this one, also corresponding angles. So I can actually give reasons for all 3, but I need only give reasons for 2. So let's do that. The first one is A equals A, and the reason is common angle. And then I think I said C equals P. And remember, it's corresponding angles. And the moment I do that, I've got to say which lines were parallel. It was PQ parallel to FE. So therefore, the remaining angle is D, and the remaining angle here is Q. Third angle of triangle. And that means we can write up the ratios now off this. So we can say ACD is similar to triangle APQ. Reason angle, angle, angle. Remember what I said to you? It must be in order if you're going to use that symbol. So in the light of that, I can now say that AC, the first two over the first two, equals the last two over the last two, equals the first and last over the first and last. And the good news is we know what these are. If we go back to the drawing, we know that AC is equal to 3A. And AC is equal to 1A, and AP is equal to 3A. So I can go back here, and I can go A over 3A equals the one I want to know about, which is the CD and the PQ. And so I need to change that to 1 and that to 3, but they told me PQ is 60 centimeters. So therefore, PQ is equal to 3 lots of CD. And since PQ is 60, CD must be 20. So therefore, CD is 20 centimeters. Back to our drawing. So we know this is 20. Excuse me. Now we have to still go and find this one over here. Now remember, we proved earlier on that those are equal and those are equal. So that means midpoint theorem comes in, which means this one is half of that one. So we can now just say that FE equals 10 centimeters. So the third one, FE equals 10 centimeters. And the reason for that is midpoint theorem. And we finished. I must admit this is quite a challenging question, but I have told you how to cheat, if you like, your order of your angles. So if you're struggling, write them in order and then look for the reasons. That will make sure you get some marks anyhow. Okay, so I think that brings us to the end of this question. So Avram, we're going to have to go from there, and I'll be back with some others. I think I won't scare you so much on the next one.
I like the fact that you also gave us some cheating skills, which could work awesome. And you know what? I've just learned something. There's a quote that says there are 4 things that will always speak to us. The first thing is pride. Pride will always say to you, it is impossible. And the second thing is experience. Experience will say, this is risky. And the third thing, it will be a reason. The reason will say, this is pointless. But one thing that will always say, give it a try, it is your heart. So it is all in the heart that is always willing to learn more and to try new things.
Correct. And you know, all these famous businessmen didn't succeed the first time they tried.
So
they
true.
failed a few times before they did succeed, and it's the same with maths.
So true. I like that. Mindsetters, stay tuned with more motivation and learning more after the break. Welcome back, Mindsetters. Now looking at the page, I'm seeing some really great comments from you guys. The first one is from Nsovo Makamu Kamza, all the way from Kamalamulele in Limpopo. Nsovo says, keep on going, we are learning more. So keep on going,
Good, that's
they're
great.
learning more. 2 more comments. Spogas in Nzalaza says, it's so awesome to be a mindsetter because the Mindsetters dictionary has no words such as failure. It only has positive words. To name one of them, it will be success. I'm proud to be a mindsetter. I like that, Spogazi. And the last one from Matsobane Minetifo. Actually, Matsobane, I actually got to know Matsobane on Saturday. He kept me very much entertained. It was a 4-hour show, but I felt like it is just 5 minutes. So on Saturday, he was very much active. Thanks, Matsobane. He says, yo, thanks for the tips, ma'am. They're really helping a lot. We'll put them into use. And you, Abraham, thanks for a great show so far. Thank you so much.
Well, I'm delighted that it's having some benefit for you, and I just keep on reinforcing, never leave something blank. No matter what you write down, you may get some marks. And remember too that if you can't prove the A part of a question, you can write, assuming A true, use that fact and carry on to B and C. So you'll lose just the A part and not the whole part of the thing. So it's always worth, and you'll see the one I'm going to do with you now. If you're stuck, you also improvise. I'll show you how you can improvise if you're in big trouble. Because what we do with geometry is we know that most students find it difficult. And we know that it's something, I mean, I remember at school I loved geometry, but it was because I grappled with it, and that's the secret, is sitting down and really getting your teeth into it and knowing about the work. So if I can encourage you to do anything, is not to give up, to always write something down, even if you think it's not really relevant, because something is better than nothing. That's always important.
So true. And that's the whole purpose of education, taking away the blank mind and putting something.
Definitely.
Be logical. Think of something.
Great. So let's go to this question here. And it's, again, demanding, not as demanding as the previous two, I must add. So feel a bit happier about it. So let's look at it. Okay, it says the following. Oh, gosh, I'll go too fast with this finger of mine. I definitely have to slow it down. In the diagram below, O is the center of the circle. Now, I always encourage my students that as soon as they hear that, highlight the center. Because the moment you have the center, you've got some theorems that work for you. So let's put it in. So O is the center. Let's make it obvious it's the center. Reading on. Chord AB is perpendicular to the diameter DC. So chord AB is perpendicular to the diameter. Now that's quite important. So this is actually the diameter. Worth writing it in just in case. Right, then it says CM is to MD. CM is to MD as 4 is to 9. And remember what I told you, you can introduce a variable, but very important, they tell me AB is 24 units. Now that's going to be useful for us. So let's go and read the first question. The first question says, determine an expression for DC in terms of x if CM equals 4x. So they've helped you out a bit. They've told you to make that 4x. Now if that's 4x, the good news is they're telling me that MD, this guy here, is 9x. Because I can't have a different variable in the fraction because that variable's got to cancel. So it makes sense, once they've told me it's 4x, the other one must be 9x. So what have they actually told you? They've actually told you the length of the diameter in terms of x. So what do I know? I know that the diameter is going to be 4x plus 9x. So it's going to be 13x. Now, I don't know if that's what they're asking me for, but we've got it for now. So it says determine the expression for DC. So DC is the whole line. Well, yes, that's exactly what they wanted. DC was the diameter. So all we would do now is we'd write this up nicely. So we'd start over here and we'd say, therefore, what was it, DM equals 9x, and that was given. But DC equals DM plus MC. We know it's the diameter, and therefore DC is 13x. And we've actually proved the question. Something I want you to notice is that I actually think it through in my brain before I start writing. But if I couldn't get to the final thing, I would write down whatever I'd managed to figure out. Like the fact that you would say DM is 9x, that's worth a mark. So it's definitely worth doing it because you're just using your ratio there. So even if you can't conclude any further, but once you do that, once you draw it on your drawing, you'll definitely know where to go. Right, let's look at the next question. The next question says, determine an expression for OM in terms of x. So let's go back to the drawing. OM, let's highlight it, is this line here. Now, of course, that's good news because we know the diameter is 13x. What is this little part of the drawing? Let's make it yellow. Hopefully you're all screaming at the Facebook and at me that that is the radius. Okay, now what do we know about a radius and a diameter? What is the relationship? Well, we know that a radius is half the diameter. The diameter was 13x, so the radius will be 13x over 2 if it's half. Okay, now you could write 6.5x, but it doesn't look as good, and it can get confusing. So rather stay with your top-heavy fractions, your improper fractions, so that you're working with something like 13x over 2. Just easier to see what's going on. So now what are we not finished yet? They want us to find this length in terms of x. And in actual fact, I don't need that radius yet, because what I know that that's 13x over 2. Then this is 13x over 2. And this one is 13x over 2. So that means I can find OM very easy. I take 13x over 2, and I subtract this little bit here. This 4x. As you can see, by the time I'm finished with the drawing, it looks like a colouring in book. But it helps to pull out what part of the question we're actually looking at. So right, going down to write up what we know that what we're trying to find OM was equal to the radius minus, I think it was 4x, if I remember rightly. Yes, 4x. Right, now the radius, as I've said to you, will be 13x over 2 minus 4x, which means we have to do some basic arithmetic. So the first thing we have to do is we have to take a common denominator of 2. So we have 13x minus 8x, which means we have 5x over 2. Right, so OM is 5x over 2. Now, you can see that these two questions were actually very nice to do. They weren't hectic. If you just keep your wits about you and you think to yourself in terms of x, you can work that out relatively easy. Unfortunately, the C part gets a little hectic. But let's assume that you couldn't work out A and B. So what you would do is you would take an educated guess. You'd say, look, it's 9 and 3, so I'll guess it's 15x. And then work with your 15x, and you'd write to the examiner, you'd say, assuming the diameter is 15x, and then carry on going as if you're normal. And then what they will do is they will use your incorrect answer on the B part and on the C part. Of course, you're going to make things harder for yourself, because now the arithmetic won't be nice, because obviously that we choose questions where the arithmetic is easy. So that's the negative of it, but you know, if you're thinking the grand plan of things, you might still get some marks, so it's worth it. So remember that as a useful tip. Okay, so now the third part of the question says hence or otherwise. Now I had a colleague many years ago who used to always laugh when they used the word hence or otherwise. He used to say hence or otherwise get it wrong. And it was basically true, because the reason they're using the word hence or otherwise is they want you to use what's above because it's going to make it easier for you. So remember, the word hence means that what you've got there already will make it easier for you. So you can go and do it another way, but the chances are you'll be reinventing the wheel. So rather use what you've got. They've tried to help you by scaffolding the question. So let's have a look at it now. So hence or otherwise calculate the length of the radius. So what do we know? I'm going to take out a bit of the drawing. Well, if I go back to the drawing, I know that OMB is a right-angled triangle. They told me that. I know that OM was given as, we found it as 5x over 2. We found this to be 13x over 2, but we don't know much about MB yet. Now, why am I saying that? Well, if we go back to the top bit, remember I said to you, as soon as they tell you the center, a whole lot of theorems come into play. And what is the theorem I'm referring to? I'm referring to the theorem that says if we draw a line from the center of the circle at right angles to the chord, then it bisects the chord. So that is equal to that. Very useful to know, and we can work with that. So now, what did they do? They told me that AB was 24. So I now know from the theorem that AM equals MB. So I would write that down. AM equals MB. The reason for that is line from center, perp to chord. Okay, and you can write words. You don't have to write these symbols. But you know, it's actually geometrics. I'm sure you know these things by now. I don't have to tell you. So that means that this would equal 12, because we were told it was 24. So now we've got a beautiful little right-angled triangle, and basically if we can solve for x, we can solve this question. So let's look at what we can use. If it's a right-angled triangle, my boyfriend, Pythagoras, is available. I've always said that if he had been alive, I would have married him because he was a very liberal man. He actually let women study maths in the day he was really, really long ago. So right, so what do we know? We know that OM squared plus MB squared is equal to OB squared. And that's Pythagoras' theorem. You've got to give reasons for everything you do. So now OM was equal to 5x over 2. And MB was 12. And OB is 13x over 2. Now obviously if you've assumed values for this, it won't work out so nicely. But you would be able to get the marks for the bits where you've actually written out your Pythagoras theorem, where you've substituted your various bits and pieces. Excuse me. Right, so if we do this, we've got 25x squared over 4 plus 144 is equal to 169x squared over 4. Now you can see this is not going to be such nice arithmetic, but it's fine, we're going to do it. So we have 25x squared. We know we don't like to work with fractions if we can possibly help it. So we're going to times by 4, so that's 7. Hang on, have I done that right? Let's just see, 4 times 4 is 16, carry the 1. 16 carry the 1, it's 576. Right, that's perfect, is 169x squared. And we have to solve for x. So we have 576 equals 169x squared minus 25x squared, which means 576 is 144x squared, which means x squared is 576 over 144. And thank heavens we've got calculators. We can, of course, just cancel down the fraction, but we know that x squared is equal to 4. And therefore, x would be plus or minus 2. However, it's a length. X represents a length. So we're not going to get the negative 1. So I can safely rub that out, assuming I pick up the eraser, of course. And I would safely say that it's equal to 2. But now, what was the question? We've done this beautifully. But the question was, hence or otherwise, calculate the length of the radius. Now, the radius was 13x over 2. If we know what x is there any problem with that? And I'm sure you're all saying, no, it's easy. It's just good old substitution. So it's 13 times 2 over 2. And, of course, that's wonderful because our radius is going to work out to 13. And that's the question done. And you can see this one wasn't so bad. And, in fact, the first 2 questions I did, I think came from the same paper. I think this one's from a different paper. I'm not sure, but it's on your notes that are posted on Facebook, aren't they, Avram?
Yes.
So you've got them there, so you can have a look where it is. But there'll always be a mix of some easy, some medium, some difficult. Obviously, I wanted to do the difficult ones with you to help you. So let's hand over to you, Avram. I hope that you've enjoyed it.
Thank you so much. Now, Mindsetters, before we end the show, I can see that already our time is against us. Let me tell you that Mindset is looking to hire someone, and we need your help. If you know of anyone who could be interested in doing grade 10 to grade 12 content development, review, and video presentation, make sure that you let them know that they can visit mindset.co.za/land/jobs, and they can apply before the 26th of August. But from us, Team Mindset, we just want to thank you. Thank you very much to you, Mindsetters, and all the best to everybody that is writing their prelim exams. Lee, thank you very much for your time.
Nice working with you. I've had lots of fun.
Thank you so much. Till we meet again.
So we meet again.
It is such a great date. Otherwise, thank you very much. We love you, and keep up the spread. Learn more, learn extra from us. Keep on believing and working hard. Peace.